Hey kids, how's everyone doing today? Hopefully you guys have had a nice little break. We are going to be starting off today with stoichiometry day 2. Now, you finished stoichiometry day 1 video. If you didn't watch that video, I highly suggest that you check that one out because I go through some examples. So this is the handout I want you to do today. So the first thing you're going to do is you're going to fill out the mole ratios. Now, we talked in the past video about what a mole ratio is. So this is a balanced chemical equation, and this says right here, 2 moles of hydrogen reacts with 1 mole of oxygen to produce or to yield or to make 2 moles of water. So 2 moles of hydrogen reacts, mixes with 1 mole of oxygen to produce 2 moles of water. All right, Mr. P, so what do you want us to do with that? Well, what we want to do is we want to fill out these mole ratios down here. Now, I color-coded it for you, so it should be super easy. But basically, we have these mole ratios, which is this. Do I have a purple line? We'll make it blue, which is this line right here. You guys see that line that I'm circling? That's called the mole ratio. You can see the mole ratio right there. Where do we get the mole ratio? What's the mole ratio come from? It comes from the balanced chemical equation. What's the balanced chemical equation? Oh man, what a horrible line. What's the balanced chemical equation? This, ladies and gentlemen, is the balanced chemical equation. We worked on those before. And those mole ratios are going to be right here. It's going to be the number of moles of B, this would be B on this side, over the number of moles of A, that would be A on that side. Mr. Pepic, lots of lines. Let's just get to it. Fantastic. So let's take a look. We have how many moles of hydrogen for every how many moles of water? Well, there's a 2 in front, so that'll be 2 moles of hydrogen for every 2 moles of water. It's not rocket science. It's just super straightforward. I did it by color, and then I also left you the little chemical symbol. So let's try this one. What do you think the ratio is here? How many moles of hydrogen do we have? That's right. We have 2. And we have 2 moles of hydrogen for every how many moles of oxygen? How many moles of oxygen, ladies and gentlemen? How many moles of oxygen do we have? That's right. That's right. We have 1 mole of oxygen. So this is our mole ratio. Again, we're going to use the mole ratio when we're changing from moles over to moles. So we're going from one city to the other. But we've already done this in a previous video. So this is what you have to fill out in class. Now, what we're going to work out here, I gave you the city here. This would be hydrogen. This city over here is ammonia. We have a balanced chemical equation, which I gave you down here. And then I worked the problem out. So if you're like, Mr. P, I don't get it, review this information and review this problem. It's the first problem I worked out in the last video. But now I'm going to show you what we have for your homework. Now you can see we have this mathematics right here, this dimensional analysis we call it, and you can see that we have 1, 2, 3 conversion factors. Where do those conversion factors come in? Well, you can see on this one we're starting at mass, so we're starting right there, and then this line right here, that's that line right there. Boom. And then this middle line here, notice it's purple. It's going to be that line right there. That's our mole conversion. That's our next conversion factor. And this last conversion factor is going to be right there until we get our answer, which is what we'd be looking for right there. So it's very straightforward. I wrote this map out for you. If you can get from McDonald's to your house, you can figure out how to use this map. But let me work out a problem, and then we'll be all done. Now you can see that in this case, we had to go, and that was the whole point of me showing that, we had to go 1, 2, 3 streets, 3 conversion factors, 1, 2, 3. So we need to choose the conversion factor, the dimensional analysis that has 3 streets on it. Your work is to figure out, part of your job is to figure out which you need. This one only has 1 conversion factor. This dimensional analysis has 2 conversion factors. And the last one down here has 3 conversion factors. So if I'm asking you right here to go from mass and then figure out how many moles we have, how many streets will it take to get from mass to moles? How many streets? I'm sure everybody can get that answer. Goes from there to there. How many streets would that be? 1. In which case, you'll cut and copy this one right here. So let me show you how that'll work. So we're going to go down. Let's look at the first question. And here it is. It says we have 15 grams of oxygen reacts with excess methane, which means we have extra methane. Okay. How many grams of water will be produced? So we're starting with 15 grams of oxygen. We have excess methane, which means we don't have to worry about it. We're trying to figure out how many grams of water. So we're trying to find grams of water. We're starting over here at grams of oxygen. We need to go 1, 2, 3 streets. So we're going to go 3 conversion factors, which means that we're going to need to copy the conversion factor where there's 3 conversion factors. So what I'm going to do, I'm going to put my cursor right above this, this dimensional analysis. I'm going to push the shift key 1 time, and then I'm going to arrow down 3 times. 1, 2, 3. Okay. Then I'm going to push Control C. I'm going to copy that information right there. I'm going to paste it right down here. Boom. Oh, Mr. P, what happened to that page? I don't know. Let's go down and get it. Let me just delete back until I can pop. There it is again. It's back. So now let's fill everything in. Remember, we always write down. So I'm gonna work in pen, and I'm gonna work with pen and my this little pen thing here, and my I don't know. You know, you type. You're typing. Sorry. All right. So let's take a look. We're starting with 15 grams of oxygen, and it reacts with excess methane. How many grams of water? So we're going to start over here. Substance A is going to be O2. What are we looking for? We're looking for water, which is H2O. And so we are going to end, ladies and gentlemen, with what we're looking for, which is right here. We're ending with water, grams of water. That's where we're going to end. All right. Where are we starting? We're starting right here. I'll put it in green for starting. We're starting right here with grams of oxygen. So let's fill that information in. Always write down what you're starting with. So we're looking for grams of H2O. Now, I don't like having a capital G because that's not the symbol. It's a lowercase g. That's what we're looking for. What are we given? We're given 15 grams of oxygen, which is O2. There's 2 of them. So if we're going to start right here at oxygen, this is where we'll be starting. We'll be starting with 15 grams. And that's what we have here. That means our first street is going to be the molar mass of oxygen. So we have to go get our periodic table. I don't have it here just because my screen is so small, but let me grab it just in case you don't know what to do. All right, so I just went and grabbed my periodic table, so let me pull it up. We need to find out what's the molar mass of oxygen. That's how much oxygen weighs. Whoops, so I went to my resources and pulled up my periodic table. Now, I'm not going to delete all this stuff. I guess I could delete everything on my screen right now, and then I just have to put it back. So you can look right here. You can see that we're working with oxygen. Oxygen, ladies and gentlemen, weighs 16. But if you can look at the stoichiometry, you can see that it's O2, which means that we have 2 oxygens. So it's going to be 16 plus 16. Let me put all my markings back. So that means my molar mass is going to be 32 grams per mole. Now that is, if I get this going, that means it's going to be 32 grams per mole. Or it's going to be 1 mole for every 32 grams. Are we going to use conversion factor A or conversion factor B? Well, let's take a look. That's right, we're going to use conversion factor B. Why? Because I have to cancel out the grams. So I'm going to put 32 grams of oxygen, O2, and on the top, it's going to be 1 mole, whoops, of oxygen. All right, fantastic. Now we have grams of oxygen canceled out. And at this point right here, you can see that we just went through this street. Where? That street is right there. Now we have to go over our purple street. So let's go get our purple street. Let me show the color palette. So we need to go get purple. Fantastic. So now we're on our purple street. So now we need to go right here. That's our purple street, our mole ratio. So this is our purple street. Where do we get our mole ratio? We get it from the balanced chemical equation. So we're working with oxygen and we're working with water. Now, are we going to put the oxygen on the top or the oxygen on the bottom? Let's see. Is it going to be 2 moles of oxygen for every 2 moles of water, or will it be 2 moles of water for every 2 moles of oxygen? So are we going to use conversion factor A or conversion factor B? Remember, we want to cancel out moles of oxygen. That's right, ladies and gentlemen. We're going to use conversion factor B. So let's use conversion factor B. I'll put it in. 2 moles of O2. Super jealous. My kids are downstairs watching What About Bob? You haven't seen it. It's hilarious. Funny movie. And I'm going to go join them soon. But here we go. We have 2 moles of oxygen. We used B. So now we canceled out moles of oxygen with moles of oxygen. Now we need to do our last street, which is going to be red. And you can see it right here. So the last street we're going to take, because right now we're sitting right here. We just got to moles of oxygen. Now we just have to go 1 more street to get to our grams. So what do we use? We're going to use the molar mass of water. So very quickly, let's go to our periodic table. Let me get rid of everything. Water is made up of oxygen and 2 hydrogens. So 1.01 plus 1.01 is 2.02, plus 16 is going to be 18.02. So the water is 18.02. Let's see if I have some space over here somewhere. So is it going to be 18.02 to, whoopsie daisy. Let me close that. I don't know if I can. There we go. 18.02 grams of water for every 1 mole, or is it going to be 1 mole of water for every 18.02 grams of water? Okay. So are we going to use A or, A or B? Right there, ladies and gentlemen. A or B. Remember, we want to cancel out moles of water. That's right, ladies and gentlemen. We are going to use A because we want 18.02 grams of water for every 1 mole, because that's our molar mass. All right. So we have that done. Sweet. We have everything like we need it. Now we just need to get our calculator. You can see we have 3 parentheses. All right. So I'll get rid of this for you really fast. All right. 3 parentheses. So the first thing I'm going to do is say, where am I starting? Whoopsies. 15. So I'm going to put in here 15. And then you can see that I have 1, 2, 3 sets of parentheses. So I'm going to put it in. All right. 1, 2, 3 sets of parentheses. What goes in the first parentheses? Let's take a look. 1 over 32. So let's go inside the first parentheses and go 1 divided by 32. Let's go into second parentheses. What's in there? 2 over 2. So we're going to put 2 divided by 2. And then in our third sets of parentheses, our third conversion factor is 18.02. So that's going to be 18.02 divided by 1. And our answer is going to be 8.446. A general rule that we've been taking this year is to take 2 numbers after the decimal place as a general rule, which means it's not going to be 8.44. The answer will be 8.45 because we have to do this thing called rounding, which I've already done a PowerPoint on. Oh, what was our answer? What did I say? 8.45. So let's go put in 8.45. 8.45 grams of water, and we're done. we finished. I'll put back all my markings so you can be like, where'd you get everything? There it is. If you're like, Mr. Pebic, I don't get it, you're going to want to stop this video and you're going to want to start it again because this video was awesome. Hopefully it wasn't too long. Kids, if you have any questions, I'll be right here waiting for you to ask me any questions. So you just let me know what you need. And that's it. Cool. Have a good day. Take care. Bye-bye.